Let's use de Moivre's theorem to figure out trigonometric identities for cosine 4 theta and as well as sine of 4 theta. So the way we're going to do this, let's let z be equal to cosine theta plus I sine theta. And we remember that z to the fourth is equal to cosine of theta plus I sine theta to the fourth power, which is also equal to cosine 4 theta plus I sine 4 theta. Okay, now let's see what happens if we just simply multiply out the left-hand side. Using Pascal's triangle, the left-hand side is cosine of theta to the fourth power plus 4 cosine cubed times I sine theta plus 6 cosine squared theta times I sine theta squared plus 4 cosine theta times I sine theta all to the third plus I sine theta to the fourth. And all of that is equal to the right-hand side, cosine 4 theta plus I sine 4 theta. Let's now collect the real and imaginary parts. The real parts would go cosine theta to the fourth. The third term would be minus 6 cosine squared theta times sine squared theta. And the last term is sine of theta to the fourth. The imaginary parts, the second term here is 4 cosine cubed theta times sine theta. And then the fourth term, first on this new line, would be negative 4 cosine theta times sine cubed of theta. And that is equal to the right-hand side, cosine theta plus I sine 4 theta. So if these two complex numbers are equal, that means that their real parts and imaginary parts have to be equal. So the real part of the left-hand side must be equal to the real part of the right-hand side. So those two match. Also, the imaginary part of the left-hand side must match the imaginary part of the right-hand side. So this must be equal to the imaginary part of the right-hand side, which is just simply sine 4 theta. So there are trigonometric identities, angle reduction identities, for sine 4 theta and cosine 4 theta based on de Moivre's theorem. Now, you could use further Pythagorean identities to simplify the left-hand side. So the obvious simplification on the left-hand side would be to factor 4 sine theta cosine theta out, which leaves cosine squared theta minus sine squared theta, which is sine of 2 theta. That is something that can be done. Likewise, you can use Pythagorean identity, sine squared theta equals 1 minus cosine squared theta on top to write the top one in terms of all cosines. Those things can be done, but just simply using de Moivre's theorem, these are the two identities that come out from just simply using de Moivre's theorem.